Hey everyone, in this video I'm going to use EditCap to show how you can do some cropping of packet captures. So I'm just going to rip straight into it and show you on the screen. Now here are the files I'm going to be playing with today. And I'm going to start off with a Wi-Fi capture. So if I go Wireshark and just show you what I'm dealing with here. Now this capture was done using a MacBook of the four-way handshake that happened between an access point and a client. Okay, so the MacBook had nothing to do with that network, it was just listening to the Wi-Fi frames as they went through. So here's what it saw. Now I filtered it just down to the EPOL frames. Okay, and as you're probably aware, message 1 comes from the AP to the client, 2's from the client to the AP, 3's from the AP to the client, 4's from the client back to the AP. So if I start with the first one, over here you can see the radio information and stuff, but the actual Wi-Fi frame starts here where it says IEEE 802.11, and in there you've got all the flags and things and all the stuff related to a Wi-Fi frame. Now what you've got to keep in mind, if I just put this back to there, this radio information, it's good information as far as the packet capture goes. You can see signal strength and all that, but that is not part of the transmitted frame. This is information that the receiver puts on there, because the receiver knows what signal and noise and that was, not the transmitter. The transmitter doesn't know how it's going to be received. So that's added artificially by the capturing process, but the actual Wi-Fi frame starts here. So just keep that in mind. Now there's other ways to do wireless captures. If you've got an Aruba system, you can use the AP itself to do a packet capture, a wireless packet capture. So you don't need a machine like a MacBook that's capable of doing it. So in that situation, what the AP will do is it'll do the capture just like that, but it has to then get it from there to some machine running Wireshark normally, maybe on a LAN or something. So what it'll do is it'll put it as a payload in a UDP packet and send the UDP from the AP to a machine. So I'll show you an example of that. Okay, now this is that same capture, but this time it was done at the AP and sent down the line using UDP. So if you go right to skip down to the bottom here, you can see there's the same 802.11 frame and its contents that we saw before. But starting at the top here, well, here we've got the frame. Now it's coming from a Raspberry Pi to this computer here. The reason it's coming from a Raspberry Pi is because it's going through a router to get in. My router's a Raspberry Pi. So the IP packet source is the access point and the destination is this computer. And you can see I'm using a 24-bit subnet here. That's why I had to go through that router. And what it's containing is UDP. So we're just using ports 5555. And within that, I'll get back to this little bit in a second, but within that is some radio information which got added again by the AP. So if I look at that, I mean, for instance, the signal strength it says is 100%. Now that's a transmitted packet from the AP itself, so it's always going to show 100% on that. A return one a bit less. Okay, but again, that radio information was added by the capture device, which in this case was the AP. But here's the real start of the 802.11 frame. Now this thing here, the only reason that's there that tells Wireshark that it's an ERM type of packet is because if you right click that and decode it, just get rid of that, I've already told it that UDP packets with port 5555 to decode as Aruba ERM and which type. So I've already got that set in Wireshark. If I didn't have those there, it would just look like a UDP packet with some sort of payload. Okay, and who knows what that is. But what I've done here is just told Wireshark that UDP port 555 to decode as Aruba ERM. And then which type, because you can do a few on the Aruba, I tell it which type of ERM, I say type 3, and that's what I did when I set the capture. So anyway, that just tells Wireshark that it's that sort of payload. But the bottom line there is the UDP is just used as a transport to get it from the AP to a device running Wireshark that you can actually save the capture. Now what I might want to do is get rid of that UDP packet, that encapsulation, and just have the Wi-Fi frame itself. So what I need to do is have a way to crop out all the stuff that's before the 802.11 frame. So I can do that with a program called EditCap. And one of the things it lets you do is just chop bits of data out of the packet. So I'll show you what we're going to do here. First of all, we need to figure out what we want. Well, if you look on the right, there's the actual bytes that are contained in the packet capture. And if I look at the start that we want, it starts at this 8802 over here, right? That's the start of our frame that I actually want. And if you look down the bottom left here, as I hover over these bytes, let me just get that back to neat. As I hover over the bytes here, you'll see that it gives you the byte number, bytes 72 to 77, blah, 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 contains what information it contains. So the first one, if I go over this 88 here, you see it starts at byte 62. That's basically saying that our 802.11 frame starts 62 bytes into this packet capture. So what I want to do is crop everything up to that, that starting byte here. So I need to start at byte 62. So what I'll do is run EditCap to edit the capture, give it a -L, which makes sure the length's still correct when it finishes, and do some chopping. And we're starting at the start, so we're starting from 0 and we're going up to byte 62. So that'll chop 62 bytes out starting at the start. And the one I want to do it to is the UDP capture, and then save it as something, call it ip capture clean.pcapng. And I've got to give it the type to tell it what type of frame this is going to be. And I'll say IEEE 802.11. So now when I look at that, what was it? AP capture. So now all that UDP stuff is stripped off, as was the radio header, and we've just got the actual 802.11 frame. And of course, all the 802.11 stuff is still in here because there's an 802.11 frame. Okay, so that's how you can strip the UDP off using EditCap. Now that's just one type of encapsulation, but there are others. For instance, GRE is commonly used, and I use it a lot. That's generic routing encapsulation. Now that's used on an Aruba system between the access point and the controller to transport that wireless frame, because on the system there, the wireless frame is generated by the controller, transported within a GRE packet to the AP, and then it's transmitted out. So what I'll look at now is a packet capture, that same four-way handshake, but this time I did the capture on the GRE tunnel from a port mirror between the access point and the controller. Okay, same sort of thing. You can see the MAC addresses are both Aruba because it was on the same subnet VLAN, so it didn't have to route through anything. The IP address is simply the controller and the AP. And here, the payload is GRE. And then it's exactly the same stuff as before, just this time contained in GRE instead. So what I'm going to do is the same sort of thing. I'm going to chop that out like I did with the UDP packet before. This one's slightly trickier, and I'll show you why. So if I have a look at this first frame, right, from the controller to the AP, the actual 802.11 data starts at, there's that 88 again, starts at byte 42. See down the bottom left, 42. Now, coming back to the controller, it starts at byte 38. So that seems to be changing if it's to the controller or from the controller. And if I have a look in this GRE bit here, you see this key. Now, when it's going to the AP, that key's there. Coming from the AP, it's not. To the AP it is, from it it's not. So if I have a look at one that has it, you can see that key, it's highlighted it for me. It's these 4 bytes. That's why the start of the frame changes by 4 bytes depending on which direction you're in. So if I want to chop that up and start at the 802.11 frame, if I start here at byte 42, let's just see what happens. Okay, EditCap, start at the start and go into 42 of them on the GRE one. We'll just call this test. Okay, and it's going to be 802.11 frame. If I have a look at that now, you'll see that frames 1 and 3 look good, but the other 2 are messed up, and that's because we needed a different length at the start of those. So, just remove that test. In order to do that right, I'm going to have to split that capture up into the 2 different destinations and then work on them separately and then merge them back together. So to do that, I could use Wireshark, or I could use tshark. So I'm going to use tshark, which is the CLI version of Wireshark really. And just to confirm, I'm just going to see what that capture looks like. So there's tshark showing pretty much what Wireshark does on its main window. But what you can do with tshark is the same things as Wireshark. You can go, same file, just use a display filter and go, okay, IP destination equals 192.168.100.9. That was the AP's IP address. And then write that as a file, a new one, to ip.pcapng. Okay, so now that's just trimmed it down a bit to just have the messages to the AP. This is from the controller, remember? And so what I'll do is do another one and have it from the AP. So IP source, and I'll create one called from AP. And if I look at that, you see it contains the ones from the AP. So going back to Wireshark so you can visualize it, the ones to the AP are the ones that have this key. So to get the Wi-Fi frame, we have to start at byte number 42. And if you remember, the other one was byte 38. So to the AP is byte 42. So now we just run EditCap, get the length, chop it up from 0 to 42, because this is to the AP, to AP, and I'll call it to ip-new, type IEEE 8211, okay, and I'll also make a new one called from AP new, and we're starting that one at 38 bytes, remember? So now, if I have a look on Wireshark at the to AP new, you can see it's just got the 802.11 frame. It doesn't have the GRE. And if I have a look at from AP new, it looks good, coming back the other way. Now the only thing left to do is to put them back together. So mergecap, to AP new, just write the list of files that you want to merge. So I've only got two, to AP and from AP new, and then make a new file, complete.pcapng. So now when I look at that, both directions are there, no GRE and 802.11 frame as it is. So what you could do, I mean that might have looked complicated, but it really wasn't. But to make that a little bit easier, you can just write a script. So if I make a script, and look at what I just did there, that's basically all I did. I split the capture into two directions, edited each one, and merged them back together again. So given that we're going to work on a file, we don't know what it's going to be called, GRE capture in this case, we could just use $1, which means the first argument that you give it, I'll get to that in a second. And for the destination, argument number 2. Okay, and that should be everything we need. So, make it executable. I'll just get rid of the old complete one that I did a second ago. And I'll just clear that and show you again what we're dealing with. So they're the files I've got in here. I'll remove the two AP ones. So starting again. Remove the from AP ones, start again. Okay, so there's my original files and this script here. So what I can do is just go script, and for the first argument, I'll give it which file we want to work on. So I'll just say, GRE capture. And as a second argument, I'll give it the IP address of the AP. So 192.168.100.9. Just press enter. That's it. So it's just created all those files. So it's nice and simple. Again, the CLI reigns supreme. Okay? Okay, so that's how to strip a couple of things out. What if you want to take something out of the capture in the middle? Now an example of that is a VLAN. So I've got another capture here with just a frame here, it's not even a packet. You can just see this frame, Ethernet frame here, and there's the payload, but you can see in here, I've got a 802.1q tag. Now if I have a look at this, what have we got here? Well, that whole thing is 4 bytes. You can see on the right, it's highlighted here and here. I am going to need that Profinet thing. So what I need to do, normally that Profinet type would be in here, but it's not. I need to chop from there up to there, so that Profinet ends up being up here. So what I've got to chop out is starting at this byte here, which is byte 12. See, that's 12 and 13, but I also need 14 and 15 gone as well, so I can start at the type Profinet. So I need to chop out, starting at 12, I need 4 bytes out of that. So I'll just get out of that. And let's say do EditCap, length, chop, starting at 12, we want 4 bytes out from VLAN 440, and I'll call it no VLAN.pcapng. Now for the type here, it's not an 802.11 frame, it's an Ethernet frame, so the type is Ether. Just have a look at that now, that the no VLAN. And there it is. Just the MAC address and straight into it. So that type moved up to here now. So now we've got no VLAN tagging. Now all I've done so far is crop things out of a frame, whether it's the encapsulation at the start or the VLAN somewhere along the way. But now I'm going to try and change something. So that frame I just looked at there had VLAN 440. I'm going to edit that and change its VLAN. So to do that, I'm just going to use a hex editor. I'll use ghex and go back to the VLAN frame and have a look. So this is how it looks as hex. Now the pcap file adds this information on how the capture was done, but that's not really part of the frame itself. That's just added there by Wireshark. So just quickly have a look back at Wireshark and see what we're looking for. Now I'm looking for this here. That's the VLAN tag. And just before I go into this, these 2 bytes here, you can see it's 2 bytes, right? These 2 bytes represent this whole 8021Q tag. But the first 4 bits of that, well, the first 3 bits indicate the priority. And of course, you can only go from 0 to 7 with 3 bits, right? So this is 6 in this case. You could edit that as well if you want. This is the DEI, and the remaining 12 bits are what you've got left for the VLAN. Now you may be aware that you can have 4094 VLANs. And the reason for that is it's a 12-bit field. So the maximum number you could represent here is from 0 to 4095, but you can't use 0 and 4095. You just use the ones in between. So from 1 to 4094. That's why it's that particular number, because of the 12 bits available in the field here. So anyway, as a 2-byte value starting from here, you got 1100, which is C. Oh, it's over here. C, and then 001 is the 1, and you've got B, then 8. So C1B8. What I want to do is change this to be 100. And hex for 100 is 64. So I want this last bit here to be 64. Where this says 1B8, I want that to be 064 essentially, because I still need this C over here to keep these first 2 fields intact. That needs to be C, and then this needs to be 064 essentially. So I need to change 1B8 or C1B8 to C064. So I'll close that down. Go back to the hex editor and look for those bytes. So I'm looking for C1B8. Okay, there it is. So there's our C1B8, and I need it to be C064. And I'll save that and close it. Now when I look at it, it's still called the same file name, but it should be different. Now the VLAN ID is 100. So you might have a capture from some system that you need to work on, but you need to change its VLAN tag. You can do it like that. Once you've got that, of course, we can spit that back out on the network with TCP replay. So if I went here and did TCP replay, tell it which interface, EMP3SO, I say loop for a while, and I say packets per second is 5, and I spit at that VLAN, which again is VLAN 100 now. If I put that onto the network, okay, and if I do a packet capture just for that packet there, actually I'll slow it down to make it a bit more easily visible. Start a new capture. If I start that out at 1 a second, you'll see the packets coming in at 1 per second, or they're leaving in this case. So I'm just reproducing that packet, but you can see I'm doing it this time with an ID of 100. And of course you could edit that in other ways and reproduce data out and put it out onto a network. So the possibilities there are pretty endless, but with great power comes great responsibility. Remember that. So anyway, that'll do for now. Until next time, take it easy.